indented, or is everything pretty printed, so to speak? These are the 4 axes, and they'll be weighted roughly in order in which you'll spend time on them, with style being weighted the least, but still important, correctness being worth the most, because that's arguably where you'll spend most of your time getting things to work just right. And the app party. So at the very last week of the class, Wednesday, August 7th at 6:30 p.m., we will meet standing up with laptops and with some cake and more. You're welcome to bring family and friends. And this will be an opportunity really just to share and demo for each other the individualized projects that you chose to do, or even your own implementations of mobile, local, or evil hangman, to share with the class the different design directions that you chose and see exactly what everyone accomplished. So it should be a fun way to end the term. The cameras, meanwhile, in the class. Technically, this class is not on the internet. It's an on-campus class only. But what we always do in the summer is try to experiment with new approaches to videography, try out new things, new experiments. This TV is new, and this is my first time using it. So again, forgive any gaps. We can fix them all in post-production. But what we will do on an experimental basis is post the videos that we're taking tonight and in subsequent classes online on the course's website. So if you absolutely can't make it some night, or if I was particularly confusing one night and you want to rewatch it, or fast forward, or rewind, or slow down, we'll start posting within a few days the course's videos so that you have those there as a reference as well. If you're camera shy and don't want to be on the internet and on YouTube and the like, we'll always reserve this swath of seats. So all of you folks will not appear in any of tonight's footage, even accidentally. So those first 2 columns of seats in the middle, if you just never want to be seen whatsoever, we'll always set aside seats there. Lastly, or second to lastly, let me introduce 2 of the fellows sitting over here, RJ and Rob, who will be on board as the course's teaching fellows, working with us in labs on Wednesdays, providing feedback on work, answering questions with me on Discuss. Would you each like to come up and say a word? Surprise. You have to talk. You just have to talk close to my chest. Because of the microphone.
Yeah. Hi. That's one word.
Rob.
I'm Rob.
So, all right, I'll redeem this. So Rob recently graduated from the college and is going to be working with us in an academic capacity over the coming years with courses like this one. RJ is a rising senior at the college and is also a teaching fellow for one of our undergraduate classes as well. So that was RJ and Rob. Lastly, before we take a break, one of the goals of bringing this TV online tonight was so that we could have a little of this in motion. So why don't we, first let me change state here. Pull this up, and let's take a 5 or so minute break. Whoever would like to come up and play Fruit Ninja on the TV is welcome to, and RJ, Rob, and I will field questions off to the side, and about 5 minutes from now we'll regroup. There are bathrooms down at the other end of the hallway. If you also go to the other end of the hallway and turn left and go down a smaller hallway, there's vending machines, candy and soda. We'll see you in a few. Someone better come up quick. So we are back, and we're about to teach all of JavaScript so that we can then dive into the project this coming Wednesday. So the assumptions I'd like to make here is, one, that folks are familiar with some object-oriented language. JavaScript, as we'll see, is object-oriented. It doesn't have classes per se, but you'll see a lot of the same ideas that you've seen in other languages. We'll focus, too, on just the very basics of syntax. You should find that it's incredibly similar to most any C-style language, C, C++, and so forth. And you will also find that it has most of the constructs, objects, arrays that you might expect in a higher level language like this. And we'll work our way from the simplest of examples to things more complex, ultimately ending with things like AJAX, asynchronous JavaScript and XML, which will underlie the programmatic features that we need for this coming first project. So first, a snippet again of HTML. So this is an HTML5 web page, but we can also call this a DOM, Document Object Model, which is just a fancy way for saying tree. Even though we draw the HTML like this, you can actually think of it like a family tree whose root node, so to speak, is the HTML node. So let's throw away the doc type declaration, which actually doesn't really fit into this mental model for now. But the root of this page is the HTML tag. And how many children would you say that this root of the family tree has? So it has 2, one of which is head and body. So there's head and then there's body. And in turn, head and body have some number of children. So head seems to have how many children? So 1. As an aside, if you really want to be nitpicky, technically head has as many as 3 children because there's some white space here and there, and there's also some white space after the title. Most browsers throw this away, and you don't have to worry about it. But as an aside, technically you could argue there's 3 nodes. All right, but we'll assume that it's just one. It's a title. How many children does the title element have? So it is 1. So we won't dwell on this, but there are different types of nodes in a DOM, different types of nodes in this tree, one of which is an element node. And an element is the result of having a start tag and some stuff, and a close tag, a start tag and an end tag, an open tag and a close tag. Those collectively compose what's known as an element. Meanwhile, this would be known as a text node. There's also comment nodes, which we don't have examples of here, but if you do open bracket bang dash dash, that begins what would be called a comment node. But we'll focus just on these 2 most common ones. So meanwhile, the body tag, or the body element, to be proper, has how many children? 2. Each of which in turn seems to have 1 child. Now there's an anomaly here. There's this href, which I didn't bother giving a URL to because it's not really necessary for discussion. But this, is href a child of the anchor tag? No. So it's not. It doesn't really fit into the same hierarchical mental model that we're describing here. So we're going to draw it a little differently. Indeed, if I were to draw this picture as a tree, just using rectangles to represent the nodes, I might draw it as this. I have a document node, and this is the detail I said I was going to wave my hand at earlier. Turns out that there is an uber node, the document node. And for those familiar with JavaScript, you might have seen this before, the document global variable. We'll come back to that. But here's our root element, HTML. Indeed, it has 2 children, head and body, each of which has a title tag over here and a child of that. This guy has an anchor tag and an h1 tag, each of which has a textual child. And then just because it definitely doesn't belong below the node, implying that it's child, I'll arbitrarily draw the attribute laterally off to the side. So it's an attribute of the node, but it's not a child per se. So who cares about this detail? Well, if you start thinking about the HTML you see and the HTML you write as ultimately constituting a tree, once that HTML is parsed, that is read top to bottom, left to right by a browser, loaded into memory as an actual data structure, namely a tree, this is what it might look like inside of your computer's RAM. And this is a useful way of thinking about it, because now that as we begin to dive into JavaScript, JavaScript is increasingly being used to take a tree like this and massage it into a different tree, adding nodes, subtracting nodes. Already, if you're a Facebook user or a Gmail user, things happen quite dynamically these days. If you get an email with Gmail, the whole page does not reload certainly these days. Instead, you just get a new row in the middle of the web page. That row is probably a tr or something like that inside of a table tag, maybe, or maybe it's a div, but something like that. How is Gmail updating the inside of its web page? It's using JavaScript to insert more rectangles like these somewhere into the middle of the page. Facebook, when you get a Facebook chat or a status notification or a tweet that pushes everything else down, what's happening? This language called JavaScript is inserting a new node or rectangle into the tree and pushing everything else down or to the side, depending on how the programmer decided to do it. So that's what's been happening all this time underneath the hood, and we'll see how to do that ourselves momentarily. So JavaScript. How do you go about writing JavaScript? Well, historically, it runs client-side inside of a browser. So if you've got a website written in PHP or Python or Ruby, you might have JavaScript in that site, but it's not getting executed by your server. It's being sent to the server via HTTP over the internet, and then the browser is reading that JavaScript code just like it reads the HTML, top to bottom, left to right, and executing it on your own Mac or PC. So where do you put the JavaScript? Well, we've seen already you can have script tags. We haven't seen them with stuff in between, but the simplest way to start writing JavaScript, as we'll see, is to just put it inside of an open script and a closed script tag, just like that. But of course, you're probably more familiar already with this format. Just to recap, what does this line of HTML do? What does it tell a browser to do? Exactly. Load file.js and treat it as a file containing JavaScript code. So if there's code in it, it should be executed, top to bottom, left to right. So we'll see how to actually embed that in a web page. What about the language itself? Here I'm going to take a shortcut and just wave my hand at all of the syntactic features of JavaScript. Why? Most of these keywords, if not all of them, are probably familiar to you no matter what language you've actually used before. A couple might be new, might not have used the for-in construct before, might not have used try-catch if you're not familiar with exceptions, might not have seen var before, but it's just what we use to declare a variable. But you can probably guess what most of these do. So Break is usually used inside of a loop or a switch to break out of it. And we'll go through this quickly. These are the details we'll come back to over time as needed. And any number of online references can reinforce. Const specifies that it should be a constant value. Continue means to do another iteration of a loop without necessarily proceeding further down below the line of code. Do while means do something again and again, but check the condition at the bottom instead of at the top. For starts a loop. For in is useful when you want to iterate over an array. It's just a shorthand way of typing out a traditional for loop, as we'll eventually